Good morning, everybody. Today we are starting with exercise, exercise 1, real number, exercise 1.2. So, in previous class, we have completed exercise 1.1 and we have solved questions based on HCF and LCF. LCM, that is highest common factor and least common factor. So, go through that video, you will cover all those questions, examples as well as exercise question. Today we are starting with exercise 1.2. This exercise, in this exercise, the first topic is fundamental theorem of arithmetic. In fundamental theorem of arithmetic says that let P be a prime number. If P divides A square, then A divides A. Then P divides A, where A is a positive number. Suppose A is a product of P1, P2, P3 up to Pn, where P1, P2, P3 are prime number. These are prime number, not necessarily distinct. Right? Now A square will be written as P1, P2, P3, P4 up to Pn, पूरा का square. Now if A square is divisible by P, then A will also be divisible by P. So this is, if A square divisible by P, then A will also be divisible by P. This is the theorem of fundamental theorem of arithmetic. So we are starting with question number 1, that is prove that root 2 is irrational. We have to prove that we have first example to be solved. So first question to be solved is prove that root 2 is irrational number. Question number 1, prove that root 2 is an irrational number. This is an irrational number we have to prove. Okay. So we will prove this with contradictory method. It's, let's say, solution. Let's assume root 2 is rational number. Root 2 is rational number, and this root 2 and A and B are positive integers co-prime number, that is HCF of A and B is 1. You must have heard of co-prime number and composite number. See, in prime number we have two factors for any number, that is one for prime number. Suppose 2 is a prime number, so 2 will have one factor 1 and another factor 2. A prime number will have two factor. One is 1 and another is number itself. Co-prime number will have HCF 1. Suppose 2 and 3 are co-prime numbers. So both will have two factors only. One is 1 and another is number itself. In composite number, you have other than more than two factors. So this is known as co-prime number. Co-prime and composite number. Hope you have understood this concept. Now we are starting with, see, this is for understanding, so you must have understood. Now start, see from here. Co-prime is number 1. Okay, co-prime numbers done. Now root 2 can be written as A by B, where A and B are co-prime, HCF1. So this is B root 2 A. A square equal to B square. This is 2B square. So A square divided by 2 is B square. Now if A is divided by, if A square is divisible by 2, that means A will also be divisible by 2. Now say this is question number 1. Let's say A upon 2 equal to C. So this A is 2C, upon dividing A square will be 4C square. See, A square is 2B square. So this is 2B square equal to 4C square. 2 goes out. This is B square equal to 2C square. Now B square upon 2 is C square. This means if A is divisible by 2, then B is also divisible by 2. From this, from equation 1 and 2, from equation 1 and 2, 2 is common factor for 2 is common factor for A and B, which is contradictory, which is as A and B are co-prime, right? And 2 is hence our supposition is incorrect, and root 2 is irrational number. Understood? So this is the theorem for, this is the solution proof of this first question, that is to prove that root 2 is irrational number. Now this another question, question number 2. Question number 2 we will we have to solve what? The question number 2 is prove whether root 3 is irrational number. So we again start with the same way. Let's assume root 3 is rational number and A, B are prime numbers, where this is to be understood. This is prime number, co-prime, rational, irrational. We have already learned in class 9. I will make separate videos for number system where we'll explain it. So for now, this is co-prime. Co-prime numbers will have HCF as 1. Now see, this is root 3. So root 3 equal to A by B. This is b root 3 equal to a square equal to 3b square. Now a square divided by 3 is b square. So if a square is divisible by 3, then a will also be divisible by 3. Here a by 3, suppose c is an integer. For any integer c, this is 3c. Now this is 9c square, and this is 3b square equal to 9c square. So this is 3c square. Now this is 3, and here it is 3. So 3 goes out. So b square equal to 3c square, b square 3c square, b square is divisible by 3, so b will also be divisible by 3. And from these two equation, 3 is common factor of a and b, which is contradictory as a and b are co-prime. We have considered a and b as co-prime number. So this is, but hence our supposition is incorrect. We have supposed root 3 as rational number. So root 3 is irrational number. So root, right? So question number 2 already done. Now we will start with question number 3. The question number 3 says, where is question? Question number 3 is question 5 minus root 3. 5 minus root 3 is irrational. So where is 5 minus root 3? See, we have to solve 5 minus root 3. 5 minus root 3. So 5 minus root 3 is an irrational number. So this is 5 minus root 3. Now 5 minus root 3, let's say 5 minus root 3 is irrational number and a and b are positive integers. So we have supposed this 5 minus root 3 is a by b. Now say okay, let's see 5 minus a by b equal to root 3. Now this root 3 equal to 5b minus a by b. 5a and b are positive integers. Why a and b are positive integers? So therefore 5b minus a upon b will be rational, right? So root 3 is rational, therefore, but root 3 is irrational, hence our theorem our supposition is Hence our supposition is incorrect. And 5 minus root 3 is irrational. Okay. So this is question number. Third question we have done. Now question number 4. This contradicts the fact that root 3 is irrational. Root 3 is irrational. Contradict the fact that root 3 is irrational. Same language will be written. You can write either, and root 3 contradicts the fact that root 3 is irrational, or root 3 is irrational, so supposition is incorrect, hence this number is irrational. Now another next question, that will be fourth example. First we have done root 2, another root 3, thereafter we have done 5 minus root 3. So this question is fourth one. The fourth one, we are dealing with examples, and once we complete these examples, we will start solving questions from exercise. Now question number 4. Okay. Question number 4 is 3 root 2. We will solve 3 root 2. Okay. See, how many of you started solving NCERT exemplar? Once I complete the solutions, complete uploading solution of this NCERT exercise, I will make sure that I upload all solution of all exercises of NCERT exemplar. Questions from NCERT exemplar are of good value. Once you solve those questions, you will have this pro level question. So don't miss those chapters from NCERT exemplar besides any other help book. So 3 root 2 is an irrational number. Let's say 3 root 2 is rational number and a and b are positive numbers. So a and b are positive numbers. We have considered 3 root 2 as rational number. Now see, same set of lines we have to write again and again, but we will write it. See, 3 root 2. They used to ask this question. One question will be asked in your exam of such type. So do it. See, this is root 2 where a and b are co-prime numbers. Thus, this means their HCF is 1. Now, root 2 is a upon 3b. Now, a and b are positive integers, hence a upon 3b is a rational number. And if this is a rational number, root 2 is unrational. Therefore, root 2 is also rational. This contradicts the fact that root 2 is irrational, and this contradicts the fact that root 2 is irrational, and hence our supposition is wrong. Means our supposition is incorrect. Okay, therefore 3 root 2 is an irrational number. Right. So question number 4 done. In question number 5, we will start. In question number 5, we will. Okay. Now these four were examples. These were examples of exercise 1.4. Now we will have exercise question, and this exercise question we will start solving exercise questions only. The exercise questions are there are 3 questions in our exercise. First is prove whether root 5 is irrational. So till now we have solved examples. Now we will start solving exercise question. So first question is prove whether root 5 is an irrational number. So we have to prove whether root 5 is an irrational number. So see, first assume root 5 as is a rational number. A and B are positive integers. Now root 5 is A upon B. Now A and B are positive integers. So okay, we will write this again and again. See here, root 5 is an rational number, and rational number is represented in the form of p by q, where q is not equal to 0. So a and b are positive integers and co-prime number. Also co-prime number for which a and b HCF is 1. So root 5 is a by b. Here, see, b root 5 equal to a. Now this upon squaring both sides, this is 5b square and this is a square. So a square by 5 equal to b square. Right. A by 5 equal to b. If a square is divisible by 5, then a will also be divisible by 5. Here it is. Let's say a by 5 equal to c. So a will be 5c. Now a square is 25 c square. Right. A square is 25 c square. How to solve? See, a square is 5b square. So 5b square equal to 25 c square. This goes out, this is 5. So b square equal to 5 c square. Now b square divided by 5 equal to c square. b by 5 equal to b by 5 b by 5. B is, if a square is divisible by 5, then b square is divisible by 5. A square is divisible by 5 means a will also be divisible by 5. Fundamental theorem of arithmetic. The very first in the very start, first few minutes, we have talk of that theorem. That is, if a square is divisible by 5, then a will also be divisible by 5. This is, if b square is divisible by 5, then b will also be divisible by 5. See, 9 into 9 is 81. If 81 is divisible by 9, then 81 will, then 9 will also be divisible by 9. Right. So this is only fundamental theorem of arithmetic. There is no rocket science, nothing. In NCERT they have written fundamental theorem of arithmetic. So let it be fundamental theorem of arithmetic only in complex type. But do remember, if a is 2, so a square will be 4. Now, so this is 4 and 2 is, p is 2, as p is a prime number, so 2 is also prime number, and 4 is divisible by 2, so this is 2. Now 2 is also divisible by 2, so this is 1. Both are divisible. So this is what we were dealing with. In NCERT they have called it as fundamental theorem of arithmetic. So take it as it is given. Unknowingly we are doing this sum only. So this is sum of class 10. So they have written fundamental theorem of arithmetic. If you are asked to solve, you will also write fundamental theorem of arithmetic only. But for understanding, understand this. 2 is a prime number, a is a rational number. Now a square is 4. So a square is 4 divided by prime is 2. Now 2 divided by 2 is 1. Both are divisible. Now from equation 1 and 2, from equation 1 and from equation 1 and 2, 5 is 5 is common factor of a and b, but a and b are co-prime, but a and b are co-prime number. If a and b are co-prime number, then what will we do? So a and b are co-prime number. This contradict contradict the fact that root 5 is irrational. Hence, root 5 is irrational number. Right? So this is understood. This is understood and explained. This was your first question. Next question is, this contradicts the fact that root 2 is irrational number. Okay, supposition is wrong. Second question was 3 plus 2 root 5. This is question number 1. Second question, 3 plus 2 root 5. Second question, 3 plus 2 root 5. This is question number 2. So 3 plus 2 root 5. 3 plus 2 root 5. Let's assume, see, 3 plus root 2 root 5 is irrational number. A and B are integers. 3 plus 2 root 5 is A upon B. 3 plus 2 root 5. See here. This is 3B plus, okay, 2 root 5 equal to 3 2 upon b minus 3. Now root 5 equal to a minus 3b upon b into 2. Right. Don't pay attention to it. I won't write these lines, and these lines will be same in each question because this is your exercise. So solve it carefully. See, where a, b, and 3 are positive integers, hence rational. And if right side is rational, then left will also be rational. Root 5 is rational. This contradicts the fact. This contradicts the fact that root 5 is irrational. Therefore, our supposition is incorrect. 3 plus 2 root 5 is irrational number. Right? So this is done. Now we have third and last question. In third and last question, we will have 3 questions. 1, 2, 3. 3 part. Again 1 and 1 we will solve. So first is nothing. First we have to prove whether 1 upon root 2. Question number 3 पहला. Prove that following numbers are one upon root 2 is an irrational number. So we have to prove this. Now let's say 1 upon root 2 is a rational number. A and B are positive integers. 1 upon 2 can be written in the form of 1 upon 2. This is root 2a equal to b upon squaring. We get this much. Now b square upon 2 is a square. If b square is divisible by 2, this means b will also be divisible by 2 using equation fundamental theorem of arithmetic. Now let's b by 2 is c for any integer c. For any integer c. Now this is b equal to 2c. Now b square is 4c square. B square equal to 4c square. Where is b written? Here it is. B by 2 is c square. So b square is 4c square. Again b square is 4c square. So we have written 2a square equal to 4c square. 2 goes on. So a square is 2c square. Again a square will be divided by 2 is c square. So a is divided by 2 is equation number 2. First equation, second equation. Both done. So equation B, if B is divisible by 2, so A is also divisible by 2. Therefore 2 is common factor of A and B, but A and B are co-prime number, and A and B are co-prime number. If A and B are co-prime number, then means our supposition is, this means our supposition is incorrect. Hence 1 upon root 2 is irrational number. Okay, understood? Now we have three questions. One is 1 upon root 2, another is 7 root 5. So we have, you must have written, see, this is 7 root 5. This is question number 2. 7 root 5. So 7 root 5, here it is 7 root 5. 7 root 5, 7 root 5 is rational number. थोड़ा थोड़ा 7 root 5 here. कितना चेंज करना है? थोड़ा थोड़ा 7 root 5 b equal to a. See there. See here. 5b equal to a upon 7. Square both ways. 5b square a square by 49. Now see, b square is a square divided by 245. केवल पढ़ा करो, याद रहेगा. a square divided by 245. Okay, understood this. What we have done? 7 root 5, 7 root 5, 7 root 5. This is a by b, so 7 root 5 b is a square. Root 5 b equal to a upon 7. So b square, 5b square equal to a square upon 49. This is b square upon a square upon 245. Question number 7 root 5. 7 root 5. Don't proceed ahead. Solve it as easy it should be. Don't make it complex. देखो, रूट 5 इक्वल टू दिस मच. अब यहाँ क्या करते हैं? रूट 5 लिखते हैं. क्या करते हैं? 7 root 5 equal to a upon b. So root 5 is a upon 7. Now this root 5 is rational number. A, B and 7 are positive integers. Hence rational. Right. So A, B and 7 are positive integers and hence rational numbers. A root 5 therefore root 5 is rational number, but therefore root 5 is a rational number. This contradicts the fact that root 5 is irrational, and if root 5 is irrational, means supposition incorrect. Therefore, 7 root 5, right? 7 root 5 is an irrational number. Done. Now we are left with last question of this exercise, and this is third. Last question is prove that 6 plus root 2 is irrational number. 6 plus root 2. Third question. Third and last one. Prove that 6 plus root 2 is an irrational number. So 6 plus root 2. 6 plus root 2 is an 6 plus root 2 is an rational number, and a and b are positive integers. See, 6 plus root 2 can be written as a upon b. Now this root 2 is 6a upon b minus 6. This a minus 6b upon b. This is rational number. Hence root 2 is also rational number. Right. This contradicts the fact that 6 plus root 2 is irrational number. Hope these numbers what I have written on board is visible to you all. So that's it for today. Tomorrow we'll in the next lecture we'll start with polynomial. We'll start with polynomial exercise to class 10. So that's it for today. Thank you for watching.